Hey there, math fans. I'm Dr. Andy Lovelace, University of Washington, longtime math instructor. I've got a good one for you here if you're beginning to celebrate Pi Day. Watch my previous videos if you want to know where the numbers for pi come from, the history. Here I'm going to begin the stuff that I think is really interesting is why pi comes up in so many things. And the first is, why does it come up in the area of a circle? I'm going to give you two of the classic proofs, and I've got a good video here with some great visuals. I'm going to be showing you some cool visuals in a second where we're going to lay out a circle. Oh, it's so beautiful. So you'll see that in a moment. Stay tuned. Very happy with these visuals I've been able to make. But first, let's start with kind of the classic proof. And I'm not giving, by proof, I'm not giving a formal mathematical piece, but I'm just saying, imagine you take this circle, take this pie. I bake pies. These are all pies I baked for Thanksgiving. My apple pie is by far the most popular. If I have time this week, I'm going to bake a pie and then do a math video with it. But that's probably, my family thinks I've lost my mind. And they're exactly right. Okay, so strawberry pie. I think this was a banana cream my daughter asked for. My kids really like pumpkin pie, so I'll start with that one. I'm not quite good enough to know how to animate slicing it yet. That's for another day. Imagine we cut it into 8 slices, as we've done on the right. And watch my previous videos if you want to know about roots of unity. I keep using those. Let's think about this for a second. It's a short thing. This will be a relatively short video, but I've grabbed it, and all the way around, so if you watch my previous videos, all the way around this entire thing is 2 pi r. That's how we've defined it. So the circumference, that's where pi comes from. Pi comes from the fact that it's pi times the diameter. It is the special number that does that. It's the number we've discovered and measured a bunch. Now, usually we write the diameter as 2 times the radius because, as we'll see in the follow-up videos, the radius is often a valuable thing for us to be thinking about. But even in the beginnings of this, some people like to work with the diameter. In the time of Euler, a couple hundred years ago, it was a mixture. Some people define pi to be twice what it is now. So over the years, it's come to be what it is, how we think of it. Okay, so let's pretend we take out the slices and we place them like this in a grid. So we make 8 slices, we put one up, we put one down, we put one up, we put one down. And the point of this is what is it approaching? It's rounded on the ends, and so it doesn't look like it's a shape we know. But if you look at it carefully, think about this shape. Or maybe even better, think about what would happen if you chopped it off here and pasted this over here. It looks an awful lot like a rectangle that's slightly rounded. And the area of a rectangle we know. And that's really what we're doing when we're finding area. Even the units of area are square units. You're trying to turn things into squares. Now, there isn't a square here, but we can say some things about this. What can we say? Well, how far is it from here to here? How far is it from here to here? Well, let's go back to our picture. How far is it from here to here? Oh, that's the radius. All right, great. This is the classic presentation. How far is it this way? Well, let's see. We've got these kind of rounded edges. Only half of the edges are on this side. So that's going to be half of the way around the circle. That's what this is. Now, all the way around the circle is 2 pi r, so half of the way is pi r. Now, that's not a whole completely precise because it's rounded. It actually is a little bit less than pi r if you were to draw this out. But the point is that if you do more and more and more subdivisions and lay them out, it's going to look more and more and more like a rectangle. So that's the part I'm relying on without a formal proof. But this becomes more and more accurate as a representation of the area of this. The more and more slices you use. And what is the area of that rectangle? The area of that rectangle is pi r times r, so it's pi r squared. So basically you see as you do this that that it's just an area of a rectangle. And you can see why the length of the circumference comes into play. So that's one explanation. So next time you're eating pizza, take out the slices. They'll get cold quick. Flip them over, and you can see it looks like a rectangle. And the length along the edge has to do with the circumference. It's as simple as that. So 3 times r squared is about the area of your pi. But if you want to be more precise, it's 3.14. Okay, that's one proof. I've seen that before. In researching this, I saw another proof I hadn't really seen before. And so I'm going to do that next. So let's get rid of this. And the other proof goes like this. Imagine you take your circle and you break it up into a bunch of layers, like looking from above. Okay? And each layer has a little bit of thickness. And this is a picture I'm going to show you in a second. But really what I'm thinking, I'll draw it because I couldn't quite make the animation exactly like I wanted. We're going to take it like this. We're trying to find the area. We're going to do another one, maybe a smaller one. Okay. Each one of these will have some sort of thickness. I don't know why I chose that color. Oh no! Each one of these will have a little bit of thickness. And what I'd like to do is unroll it. So I'd like to unroll, and I'm going to show you the visuals I made, which I'm pretty proud of. I'm going to unroll this first one. And let's think about how long it is. Well, that's going to be the circumference. That's going to be 2 pi r. Let's think about how thick it is. Well, that's going to be whatever the thickness of that first one is. So I'll put a little question mark. I don't know yet. Okay, so we've made it a little smaller. Sometimes if I was labeling this, I might want to label this change in r, but that feels a little too mathy. But we would like to label this whatever it is, 0.25 or something. So the area of that first strip is going to be, and there's an imprecision in this because the radius is not the same everywhere in there, but it's going to be about this. So then we go to the next strip, okay, and then we unroll it. Now it's a little shorter because we've now have a smaller radius. In fact, this is going to be, if you wanted to know this length, it would be 2 pi and then r minus whatever this change is. This would be this. And then we're going to keep doing it with each one. The clever thing is, let's look at the picture when we're all done of all those layers together. The first layer, second layer, third layer, fourth layer, fifth layer. And you get a certain shape. I don't know if you can see it here. It's not a rectangle, it's something else. It's a triangle. Now the proof I saw expressed it kind of more in a pyramid shape. But if this is true, and if we go smaller and smaller and smaller, it's gonna you can see there's a little gap there, but it'll get closer and closer to the accurate answer. That's the calculus part. This bottom one is going to be 2 pi r. That's how long it's going to be from here to here. This we can think about. If you add up all these thicknesses, the thickness of the first one, the thickness of the second one, the thickness of the third one, that's going to add up to r. So what do we have? Well, you say, well, that doesn't quite work. Well, the area, it's a triangle now. So it's 1/2 2 pi r times r, pi r squared. So I thought that was kind of cool, but I thought more cool if I could show you a visual. So here you go. I've been playing around with this. So this is one where basically I have it. I made it thick, so it's not perfect, but let's unravel the first one. Let's see that again, because I think I wasn't in frame. Let's make this a little wider. And here we go. That's beautiful. It's just circular motion. There's so many things you can do with circular motion. I had to think for a bit about how to make the circular motion. Then I made a parametric line. but it's not that bad to do that. Next one. Now, because I'm zoomed out, they kind of look overlapping because I've made it kind of. Next one. Oh yeah. Next one. That was fun. So each one of those, the length is that, and you can see this triangle forming. And I was like, well, that doesn't look that great, so I did it again. So here's the same thing, but I have them all going together. That was fun. But I couldn't find a nice way to use different colors to have them all go at the same time. That's maybe a project for another day. But here's what I'm going to do. Just sort of wrap this up. Make this a little bigger. Now you can't see my face. That's the best part. Okay, so here we go. I made it nice and big. All right, you can see. I don't want to show you my face because then you can see all my tricks for how I made it. What I'd like to do is have there be way more subdivisions. So I'm going to add more subdivisions. Now you're not going to be able to see this, but I'm going to make it 5, 6, 7, 8, 9, 10. So there's a whole bunch of little slices in there I've made. Now let's let it go. Boom. They're too fat. That's what everyone says to me. Okay, here we go. I'm going to thin them out a little bit. And let's see it in action again. Maybe 10's too much. Let's chunk it down to 6 and watch it go. Unravel. Man, that looks great. Let's make it much thinner one last time. I'm going to make it these slices very thin. I think then it's going to look better. So there we go. So now there's some gaps because I've made them so thin. That's why I didn't have them thin initially. Unravel. Oh man, that's cool. I'm going to do more subdivisions. Let's let it go again. Boom. One of my favorite visuals I've ever made. Hope you're enjoying this. I'm going to keep going. I'm going to get as much out of it as I can. Simple circular motion. But I'd never seen that before. How about another one with 9? Boom. And the point is the area of the triangle, the area of that triangle I'm forming should be the same as the area of the circle. It's 1/2 the circumference times the height, which is going to have to be r. 10? Anyone? Let's make them last thing because I just don't want to leave this. I'm enjoying it too much. Last one, I'm going to make them pretty darn thin. Let's zoom in a little bit so we can see them. So here's very thin 10 subdivisions. Oh, man, that looks so good. And then I'm going to do 20 slices. You ready? Give me a like or subscribe here. I feel like this, like I said, I thought this was pretty darn good. You're going to see it. That's all right. You can see this work. Let's move this over. Let's move this over. And let's let it go. There's turning a circle into a triangle. A lot of fun doing that. All right, I think I've had enough. Hope you found that interesting. Really, this isn't even the main place where pi is so important. Pi is involved in arc length, and that's the main reason we use pi in radians. I'll do that in a follow-up video. Give me a like or comment if this was helpful to you. I just thought that was pretty cool. Oops. I messed it up. I just thought that was pretty neat. All right. Thanks for listening.